So today we're going to look at vectors and the basic things about vectors. And I always like to tell people to think of a vector as a journey. And it's the journey that is important, not the starting point or the ending point. So although in my diagram here I have a vector little a, notice it's in bold as it will be in your exam paper, which does go from A to B. So I've defined the vector from A to B, that's the notation as A. Yes, it goes from A to B, but actually if you look further down it also goes from P to Q. Same journey, different points. And in fact, anywhere on my grid I could put the vector A, so there's another example of the vector A down there, which actually doesn't go between any particular points at all. It's just the vector A, and that is the journey. So don't get tied down with the points. Little things to notice, 2A is just in the same direction, there's one and there's the second one. Okay, so 2A is twice as long in the same direction, and minus A is the same vector but backwards. Okay, so it is parallel but going in the opposite direction. Now we can also treat vectors as column vectors. Okay, we can write them in this form where we have an x component. So I'm going to write that there, x component, and the y component. You'll be used to x coming before y in coordinates, so you wouldn't be surprised to see x coming before y in column vectors as well. And you can see what that means. For any one of my copies of the vector A, I'll use the one down in the bottom here, I have gone 3 across and 2 up, and so it is 3, 2. And obviously the vector 2A, that was this one here, well, everything's been doubled, and you can see I say it's 2 times 3, 2, and we just double both the components to get 6, 4, and you can see it is indeed 6 across and 4 up. And minus A, well, the minus sign goes in front of the column vector, and then you do the minus sign to each of the things. So we get minus 3, minus 2, and if you look at that on the diagram, you can see that we do indeed go 3 backwards, so that's minus 3, and then 2 down, which is minus 2. And we can generalize that, if you look at point 2 here, to add or subtract multiples of column vectors, we just treat the x and y components separately and do the obvious thing. And we'll do that in a minute in this question. So let's look at the question. There are a couple of vectors on the unit grid, and the first thing we're asked to do is to illustrate the vector a plus 2b. Well, when we're adding vectors together, we just do the obvious thing. So I'm going to draw a copy of the vector a there. Okay, there it is, put a on there, and once I have made that part of the journey, I start at the end of it and I do 2b. Now I might do that as b, like that, and then another b like that, or I could have done it as I did on the diagram on the left as 2b all in one go. Anyway, the journey is important. Where have we started? We've started here, and although we've gone round the houses and ended up down here, in fact the vector a plus 2b is from the start to the finish here. It looks like that, and we label that a plus 2b. So that's part A. And then part B, well, 3a minus 2b, we just do it. 3a minus 2b. Well, first of all, I suppose we need to see what the two vectors are. So we can see from up here, if I put it on the diagram, A is, well, it's how far do I go across to get from the start to the end? I go 2 across and I go 3 up. And for B, I go 1 across and then I go 2 down. So that's minus 2. So 3a minus 2b is 3 lots of 2, 3 minus 2 lots of 1 minus 2. And then as I say in the blue box, in key point 2 there, I just treat the two components separately. So I do 3 times 2 minus 2 times 1 to get the x component. So 3 times 2 is 6, but we'll do it in stages. 3 times 2 minus 2 times 1 for the x component. And then for the y component, we do 3 times 3 minus 2 times minus 2. So we'll write that in, 3 times 3 minus 2 times minus 2. I'll just put that in a bracket to make it clear because of the minus sign. And then we just work out the two things. As I said, 3 times 2 is 6, 2 times 1 is 2, 6 minus 2 is 4. And the bottom one, 3 times 3 is 9. And then I've got a minus times a minus, so that's a plus. So minus 2 times minus 2 is plus 4. 9 plus 4 is 13. And the vector 3a minus 2b as a column vector is 4, 13. If you had a bigger grid, you could of course do it on there, but it did say work out rather than draw. So that's what we've done.